Let z vary directly as the square root of x and inversely as the square of y. When x equals 100 and y equals 5, z equals 4. Find the constant of variation. Find z when x equals 0.04 and y equals 3. Well, there's almost 3 pieces to this problem. The first thing is we're trying to figure out this z varies directly as the square root of x and inversely as the square root of y. So let's deal with just that sentence. Varying directly, what exactly does that mean? Well, in the context of this problem, z varies directly as the square root of x means z equals the square root of x. But there's some constant of variation. We'll get to that in a second. Now, z varies inversely as the square of y. That would be z equals 1 over the square of y would be y squared. Now we have to put these two pieces together. Z equals the square root of x over y squared. However, there is some constant of variation. And this constant of variation, let's just call it k. So right now we have a formula z equals k, the square root of x over y squared. Well, how do we find this constant of variation? That's the next piece of the puzzle. We look at the information given. We have x equals 100, y equals 5, and z equals 4. So if z equals 4, I'm going to say 4 equals this k. X equals 100, but that's really the square root of 100. Y equals 5, that's really 5 squared. So 4 equals k times 10 over 25. I could look at this k, 10 over 25, and really flip and multiply 25 over 10 to both sides. Therefore, 25 times 4 is 100. 100 divided by 10 is just 10. So I know k equals 10. So my final formula is z equals 10, the square root of x over y squared. This is going back to this formula. But now they say find z when x equals 0.04 and y equals 3. Well, now I just have to plug numbers in. 10 times the square root of 0.04 divided by 3 squared. Quick computations show 10 times the square root of 0.04 is 2 over 3 squared is 9. So z equals 2/9.